Today's topic of discussion is hydrocarbons, which is an 11th standard topic. So in hydrocarbons, we have alkanes, alkenes, alkynes, and aromatic compounds. And before we start the chapter, I was interested in, the origin of methane. All the hydrocarbons, that is alkanes, alkenes, alkynes, and aromatic compounds, not only this, even nitrogen, oxygen, and some sulfur compounds, they are contained in petroleum. Probably methane had its origin from the interstellar activity which had happened uh, when the Earth came into existence. So I wanted to find out what is the origin of methane, or how did this name methane come into picture. So this name methane, it was coined in 1866 by the German chemist, who was August Wilhelm von Hofmann. He gave the name methane. Meth meaning colorless, odorless, flammable gas, and un means containing carbon and hydrogen. So methane has a lot of names like marsh gas and methyl hydride. So these are a few to name. So going on, not dealing much with the history and the rest of the story, we will go directly into the chapter of alkanes and start with its general formula. The general formula of alkanes is CnH2n plus 2. This is the general formula of alkanes. So if you substitute n equals to 1, you get CH4, which is called methane, the compound we had a long discussion on, its presence, its discovery, etc., etc. So going on to the second member, n equals to 2, we get C2H6. This is ethane. N equals to 3, C3H8, and it is called propane. N equals to 4 is C4H10, which is butane. Are you thinking I'll continue with this list? No more. That's all. C5H12 is pentane. You are familiar with the 5-sided figure pentagon, 6-sided figure hexagon. Yes, ask me. And the name springs from, those 5-sided figure, 6-sided figure, pentane, hexane, heptane, with the formula in its correct place. All right. So now let me go to the molecular structure of each compound. So we have methane with carbon with 4 hydrogens, and these 4 hydrogens are arranged tetrahedrally. So you have a regular tetrahedron, and each hydrogen are at the corners of a tetrahedron with an HCH bond angle of 109.5 degree. Each HCH bond angle is 109.5 degree. So if you see the further details of methane, I wanted to write a bond line formula, but the bond line formula of methane is just a dot. It's non-existent. Going on to the next compound, ethane, C2H6. This is the structural formula of ethane. This is the structural formula. Why do you call it the structural formula? Because the structure gives you a clue, not in 2 dimension, in 3 dimension, of course, regarding the arrangement of the atoms in space. So this is the structural formula of ethane. Now, let's try and write a bond line. We have written the condensed, the structural formula, then the bond line. I'm trying to depict a carbon here and a carbon here. If you see, the actual bond line is just a line. So this is the bond line formula of ethane. Going on to the next member, which is propane. Once again, the structural formula. Remember, carbon has 4 valencies, so north, south, east, west has bonds. So I'm not writing the hydrogens, it's understood. I'm interested in the bond line formula. I'm initially writing the dots just to show the corners and the edges having carbons. You actually can write it this way. So this is the condensed formula. This is the structural formula. And this is the bond line formula of propane. One more last, C4H8. So first draw the skeleton. The framework, the carbon framework. And then you insert the bonds. 4 lines should be seen in each carbon, and then you fill up the hydrogens. This is how you could systematically draw the compound structure. Okay, and not make a mistake. Yes, I am speaking about butane. And the bond line is 1, 2, 3, and 4. Zigzag it. Don't make it in a straight line. The zigzag gives you an idea. The edges and the corners give you an idea that the carbons are present. All right. So what is the use of, why are we discussing? Because it is there in the 11th standard curriculum, alkanes. But besides that, any other use of alkane? Yes, C1 to C4 is used in natural gas. It is bottled, in cylinders in as a petrochemical. All right. So going on to the other aspects of hydrocarbons, we'll keep this discussion very simple today. I have methane. Let me reduce a hydrogen from methane. I get a radical. This is called a methyl radical. Radical is a species which has a position to be filled up or which lacks a hydrogen. Say I can fill up the 4th valency with any functional group, a hydrogen, a carbon, anything else. So this is simply called a methyl radical. Similarly, if you take out a hydrogen from ethane, you will land up with an ethyl radical. And C3H8 minus a hydrogen gives you a propyl radical. So this is ethyl and this is propyl, so on and so forth. You understood the logic? That's very important for me. So now let us continue the discussion further with, a few things like rules of, naming compounds. Simple ones are methane, ethane, propane, butane. If there are branches, what we mean by branches, I'll just tell you. So we are going on to the rules for naming hydrocarbons. First, let me give you something called a carbon here. Let me call it a CH3. Yes, you identified the radical. I just taught you this is a methyl radical. This is methyl. So this methyl group is a substituent or a branch of the main chain, which is butane. And how do you count the branch from right to left or left to right? You should see that this is called the substituent rule or the locant rule. You would locate the lowest number for this substituent. And how do we name it? I would not complete the chain. It is understood the requisite amount of hydrogens are present in this chain. So this would be called 2-methyl butane. So it is by rules, it is by IUPAC rules that the substituent to be written first. The substituent is to be written first, followed by the rest. So this was the first rule. We can call it the locant rule. The second, say you can identify this as an ethyl, C2H5. You can write CH2CH3 or C2H5. It means the same thing. So we have, let's number it from left to right. So the location of the methyl is on the 2nd carbon, and the location of the ethyl, according to this numbering, is on the 3rd carbon. Let's add it up. So the total is 5. Now let me do a numbering from the other side. So the methyl is on the 4th carbon and the ethyl is on the 3rd carbon. So this comes as 7. So this is the wrong way of numbering the chain, where we are following the lowest addition rule. lowest addition rule. So according to the lowest addition rule, this is the correct numbering. So how would you name this compound? On the third carbon, we have an ethyl. So you've got to follow along with this addition rule. I'm teaching you another rule, which is called the alphabet rule. So the third carbon is having the ethyls E first. So you are to mention alphabetically E first. So 3 ethyl, 2 methyl. And then because the parent chain is of 5 carbons, you would call it pentane. Okay, so I finished 2 rules together. Next, we go to the next compound on the list. Say we have a methyl and a methyl again. So I've taught you the lowest addition rule. So you wouldn't make a mistake, I hope, in this compound regarding the location. So the use of di, tri, etc. So if a group is repeated twice, so you would call it di. All right, di what? Methyl. So this compound, according to IUPAC, is called 2,2-dimethyl butane. So I have taught you the dry rules. Now let's go to the next rule. I'll tell you, have patience. This is an ethyl, as you can identify. I'm writing it. And then, so if you count from right to left, you have on the third carbon methyl and on the fourth carbon ethyl. So there's another IUPAC rule which says that you would prefer the alphabet to be written first with the lowest number, with a lower number. So the ethyl on the third is preferred compared to the methyl on the third. So this is called the alphabet rule also. So we have this compound as 3-ethyl, 4-methyl hexane. I am dealing with IUPAC names. Please do remember. Next, there are a number of rules to be explained, but let us go to this. In this, I have a branch which is called isopropyl. Please hang on. Isopropyl, this is the common term I've used, the common term of nomenclature. So please hang on for my next recording, next videos, which will be aired, where I would be teaching you common names. For the time being, we will call it isopropyl, and why isopropyl, and the rest of the details, we'll discuss it in the next lesson. So going on to the name. So this is an octane. And you can see on the fourth carbon, I have a branch followed by branch of a branch. So how are the branches of branches named? You can definitely call it for isopropyl octane. I would have no objection to it, or the IUPAC would have no objection to it. But if you want to write a purely IUPAC name, this would be called, on the fourth carbon, we have an ethyl group identified by you. This is ethyl, right? Ethyl has a methyl. So you would write on the fourth carbon, put a hyphen. I hope you know the hyphen and the comma rules. In case you don't, I'm just telling you now. So we have 4. This is an ethyl. On the first carbon, you have a methyl of the ethyl. So for 1-methyl ethyl octane. That means on the fourth carbon, we have an ethyl. Fourth carbon, we have an ethyl. Fourth carbon, we have an ethyl. Always give hyphens between brackets and numbers, hyphen between a word and a number. And between two numbers, you are given commas. So these are the common, things you've got to stick on to. So on the ethyl group, I have a methyl on the first carbon. See the numbering. This is 1. That means the connect between the main chain and the branch is the first carbon. So we have 1-methyl-ethyl octane. So I have taught you the last rule, and that is the discussion, keeping the discussion very straight and simple. We wind up for today's session. Thank you for watching.